an application called MRP Panda that's going to interface with various ERP systems, and effectively anybody that manages physical inventory is going to be my customer demographic. So I'm a guy that wants to do all that stuff. So that's the main driving force behind the stream. This is not a influencer stream. You are not looking at an influencer. Just consider me a working man just like yourself, with aspirations like many others. And while it would be nice to eventually get some monetary gain, from streaming, that is not my aim, nor is it my expectation, if that makes sense. However, I will say that for me particularly, the other side is that I am actually actively learning the stuff that I'm reading to you. So we're literally on this stream, I call it my coin term, FO. Wait, fly on the wall. Fly on the wall. Fly on the. Okay, that's not a good acronym. I was trying to think of a good. You can't really pronounce it, but I call it fly on the wall learning. So that would be FOTWL. FOTW. Photo. Yeah, terrible. But anyway, that's the idea, right? So we're not going to be directly interacting on this stream. However, I am aiming to, in lieu of that interaction, since the focus here is primarily for myself to learn this stuff, because I don't know it yet, I will in turn try to convey value, because I get value from the stream. Just it keeps me, it's motivating to know that even if just one person is watching, right, that kind of a thing, keeps me on a schedule, yada yada. But I will try to convey the value of what you might get normally if you were to join, like I don't know, like I watch Soding. It's TSODING. If you don't watch that man's streams, you should. They're incredible. But I am not that guy. He's incredible. He just builds random things. I'm not there yet. We're actually learning Swift together. I'm going to read the book to you. That's what we've been doing. So we are episode 36, which roughly 3 hours per stream. So you can, do the math there in terms of how many hours we put in here. And that's just going to continue. There's no substitution for just the raw learning path. So that's what we're doing. I read this book to you. We go through the code. I voice all of my concerns. I consult with ChatGPT, the Oracle, as I call it, quite often, so we understand the concepts. We will put whatever concepts that I have to work through in my own brain, on a board that I will share later. So we're just amassing a lot of the notes. And after we get through this book, so we're almost done. Well, I say almost. We're on the tail end, 583 of 818 pages, right? After we're done here, the focus will turn to SwiftUI. So in a similar fashion, I'll be stepping the stream and myself through a SwiftUI course. So that'll cover Swift, SwiftUI. After that, we're going to jump into some effectively schema design / API design for my application. And then after that, we're going to hop right back into another Big Nerd Ranch guide, which will be specific to the Apple platform. So this is a Swift programming book. The next one that we cover will be an iOS, macOS focus book in terms of how all that works, which I don't really know much about it yet, so I can't tell you much about it, but that's what's going to be next. So once we're done with that, that would mean that we covered, deep dive into Swift, SwiftUI, and then the Apple platforms and their APIs. After that, we'll actually start building the application that I want to sell to everybody, maybe to you. You never know. But yeah, that's the intention here. So if that sounds good to you, if that interests you, then stick around, brother and sister. If not, then get the hell out. No, I'm playing. But that's what we do here. Can you imagine? But yeah. So with all that being said, now we can we can move to the recap portion. So we'll take a look at what we did yesterday, and then we'll get into it. And the only other thing, what was I going to say? Oh, yeah. So just generally speaking, I like to say this at the beginning of every stream. Well, just if it feels true to me, and it still feels true, and it feels more and more true every single day. Swift is a pretty, how can I say that? Pretty bitchin'. That's a good word. It's bitchin'. I like it a lot. I really do. I worked for a service company that resold an ERP package and also had an in-house manufacturing software program that was directly integrated with that ERP package. And so that's where all my experience came from. I wrote SQL for a very long time. Lots of SQL, love SQL, know SQL well. I would consider myself an expert in SQL, and I would consider myself, like, if we're using like Morrowind classes, because that's the only, that's my main reference when I think of a class system. They have, what's the lowest rank? Like novice? I don't think they use novice. Or maybe it was novice. Anyway, then it went to journeyman and then adept. And then master, or maybe expert and then master. Anyway, on that spectrum, I would say I was an expert at SQL and only adept at Golang. So I did have some opportunity to write programs, put them into production, ETL type of programs with Go. But that's my frame of reference. Okay, so you're not watching a hardcore programmer. So there is some element here of raw learning as well. Okay, so now the stage is set. So now we get into the recap. So yesterday, I think for the most part, actually let me check. For the most part, we've gone through the main concepts of the book, which is exciting. Because now we are here. Yeah, so we are here. Look at that. We've covered, to this point, types, constants, variables, conditionals, numbers, switch statements, loops, strings, collections and functions, arrays, optionals, dictionary sets, functions, closures, enumerations, structs and classes, initializers. Some of these are kind of fall under the umbrella of others. Protocols, extensions, generics, that was a doozy, and error handling. So we've gone through all of that. We only have, memory management, equatable, comparable, hashable. Those are protocols, property wrappers, and then section 6 down here we get into applying some of this stuff. We're going to write some apps apparently. So we're only 1, 2, 3. We got 3 more sections, 3 more chapters. Pretty sick of like direct raw content on the Swift language. It's pretty crazy. So this has been a really great book. I don't have any affiliate links for you guys. Okay, like I said, this is not that kind of stream yet. Don't hold me to it. But for now, there's none of that BS, right? So if I tell you something is good, brother, it's just good. And also, I'm not affiliated with any of it, so you can trust me, at least for now. Now, if I start pumping you for money and showing ads, maybe question me a little bit. But for now, this is the raw, unadulterated truth. And this is a damn good book. And it's worth a buy, even if you watched, every episode of me reading it to you. I think it is so good that it is worth supporting just on the purchase alone, even if you didn't even feel like you needed it anymore after watching the stream. You know what I mean? But yeah, just a great book. So highly recommend the Big Nerd Ranch Guide series. They have a ton of books on all kinds of programming type things. So go and check them out. But that's what we're doing. That's the content. All right. So yesterday we wrote the first pass of we're still doing error handling. So that's what this compiler that we're building is relative to. And so really there's not, okay, there were a few things. Now, okay, I see one. So they mentioned this concept of the way Swift handles modules. And we didn't dig into it too far, but they said that the module well, let's just take it like this. Most people are using Swift to write iOS apps, right? And the book told us that generally speaking, you don't really even have to worry about modules. And when I say modules, I'm talking about this right here. It's the Swift dot. So Swift would be the module. And error would be the, I don't know if Go calls them packages, like relative to a module. I don't know what, or this is a protocol, duh. I do know what that is. So yeah, so this is the package name and this is the protocol. And they were showing us this because obviously error, same word, right? Well, this error type is ours. We define this as part of the example that we were writing as a nested type of this Lexer class. And we wanted it to conform to the, excuse me, I don't know why streams just give me hiccups, I don't know. Enum error, and we wanted it to make it conform to the protocol error from the standard library. But we get an error that it depends on itself. You can't do that because it thinks that we mean the type here, error, that we named. So to avoid that, we just have to be more specific and do module dot protocol. So it's just a way to specify if you need to. But other than that, we didn't dig too deep into like the hierarchy of modules and whatever might be beneath it. I'm still not really clear on that, to be honest with you. We did talk about accessors a bit, but you know, that was kind of one ear, you know, right out the other one. So, but we'll cover all that again. We're going to go back and do the challenges once we finish the book. But let's see. So what else from yesterday? A lot of it was, I don't want to be too redundant because most of it is just understanding the code we actually wrote, but these are concepts that we already covered in that sense. So I won't put you through that there. Oh, asserts. Yeah, this was a big one. So we found out Swift has assert, which is a way that you can effectively guard against a particular conditional. So if you don't want the code to proceed, if it should no longer execute past the point of a certain condition not being met, you can use assert or you can use precondition, which we'll talk about the difference in a sec. But what this is saying is that this right here needs to be true in order for everything else to continue processing. Otherwise, if this first conditional isn't met, so if the position isn't less than, in this case, the end index of whatever the input is of a string, which is basically a way, like in the context of this Lexer, is a way to ensure that you're not getting one, that you're not getting an empty string, and two, that you're not reading past the end position of that index. So you're not going past it and then getting a overrun error, or what would that be, a buffer overrun or whatever. So if the first position or first argument isn't true, then in the second argument you can give it a specific string to return. That way you can, you know, return that in your error message. So the difference between, well, okay, so that's assert, right? That's how you can assert that a certain thing should be before further processing, which is cool. But assert only works in debug mode. Which means when we, like, okay, by default, Xcode and Playgrounds, which is the file that we're in, Playground, by default, those are in debug mode. So you don't have to really do anything necessarily. However, with assert, this assertion in your code would be stripped out when you actually went to go and build your application. Like, let's say you're going to go publish it on the Apple Store, right? The compiler, you know, provided all of the assertions that you have are not failing, right? And everything looks correct according to the compiler. When it builds it, it's going to rip out these assert statements. Like it's not gonna do these checks basically. If you wanted to keep that conditional check, so just as you wrote it here, but you want it to carry over into your production application, you use precondition instead. Yeah, I did. And if you do that, this will, it'll propagate through even your production build. Now they did say, and this is always a hairy one because it's so hard to quantify, but they did say that there is, that there are optimizations that occur when you use preconditions. So effectively, if the compiler can remove the overhead of having that precondition, it will. But if it can't, then there is slight overhead that you're introducing, right? Ain't nothing free, brother. Okay, so that's basically that's your weighment, and that's what you would have to take into account when making the decision between the two. And of course, in terms of how you would choose one or the other, they gave us the example of F&O. So if you ever hear that term, finance and operations. So like banking applications or anything that handles your books, like ERP applications. They're managing your general ledger. Those transactions, debits and credits, they got to balance. Those are represented by two, oftentimes those are represented by completely isolated SQL statements that run, queries that run in parallel or back to back to achieve the result. But a lot of times those processes are unaware of each other. So it just has to be right. You have to get it right. And that would be a good situation where you might want to use a precondition kind of a thing to make sure that it always balances after you're done doing whatever processing you're doing. Okay, so beyond that, did we see anything else new? Let's see. While loops, we've seen those. We've seen the switch statements and the case, the different cases. Everything else I think we've covered previously, just from other chapters. So we remove that. Let me just make sure it runs. If it does, then I think we're caught up. Nice. Okay, so Lexer output number 10 symbol. Yeah, so all in all, this evaluate is using the entirety of this Lexer that we just wrote. So actually, let me just describe it real quick for my own getting in my rhythm mode, and then we'll start. Okay. So first we import Cocoa, which I don't know what that is yet still. Well, I know it's a framework, but other than that, I don't know. So then we had an enum, so a value type. Enum is a value type token, and we made it conform. So this is a syntax that looks very much like a type annotation, because it could be, except custom string convertible is a protocol. So this is just saying here that we want this type token to conform to the custom string convertible protocol. And inside we have the two cases. Oh yeah, this was another one. We didn't learn this yesterday, but I had to be reminded of this yesterday. But there are some cases where you'll see, here, this is how you write conforms to a protocol. But it's also the way that you write, if it was just any other type, you would write it the same way, right? But inside the enum, it's a little bit different, but it can be thought of the same. So the parentheses now, inside the parentheses, where we would normally see this like in a function signature, that's not the case here. So with the enum next to the value, so case number, if we put int here inside the parentheses, that's a way of saying that it needs to be an integer. Like that's the type of it. So this is it's an associated type. as they call it. So whatever value ends up being in here will need to be an integer. Okay, so we had it conform to custom string convertible. We have these two cases, and then we have the description property, which is a string, and this is what is required to conform to custom string convertible, having a minimally a readable value name description of type string. And so this is just a conditional switching on little self, which little self will refer to the instance itself. So whatever the object is at runtime, it will refer to itself. And so it's saying if the character that it's processing is a number, or an integer rather, then return the number. If it's a plus, then return this string symbol with the addition sign. Okay, so that's the first enum, 2 switches. Then we write the lexer itself, right? And this, anytime that you see a type inside of another type, that's a nested type, which is different than a subclass we learned. 2 different things, but we won't use, I don't plan to, I mean, we're going to cover them if the book covers them, obviously, because we have it on screen here, but I don't plan to write any classes in my application directly, so actually, I don't know why I'm saying that. I mean, it doesn't affect what we learned. I'm just saying that there's a difference between subclassing and nested types, which I did not understand yesterday, but now I understand. So that's what I really should have said. And that's all that I'm trying to say. So this is a nested type right there. As is, I thought we had another one. Nope. Okay. But doesn't matter. But the point was from yesterday that they wanted to explain to us is that it makes a lot of sense to nest your types like this inside of another one. So lexer being the other type. If it makes sense, like meaning if the type itself is only relevant to the parent type, which in this case it is, because we want to say specifically that this is an error relative to the lexer type. So then we can call lexer.error. But we'll see that in a second. Okay, so we have the nested type error. And then we want it to conform to the Swift error protocol. Which, of course, that's the only requirement right there, having a property invalid character. And then let input, so this is our constant, and eventually ends up being our string that we get passed into. So that's where we hold it. So that's the constant. And then we have a mutable variable position of type string index. So this is another, that's effectively what this would look like if you were calling a nested type. Or no, sorry, that's a module name. Ignore that. But this is what giving like in this case, we're saying position is of type string.index or string index, not just string. So 2 different things, and this is a nested type. So that's how you would define that. Now, this is our initializer, and that's where the, this input here. So when we initialize an instance of a lexer, we pass in a string, and then it gets stored here in this constant. And then we need the self dot because we're referring to the instance itself. So that's what the self dot's for. And so we're making the input, which where is the, oh, okay, yeah. Yeah, so we make the input equal to the string that gets passed in here. And we make position, where are these? Oh, duh, right there. Excuse me. Then we make position equal to the starting index of the string so that we can just iterate through it. Okay, then we needed a method. So this is a method with no arguments, so peek. No arguments there, hence the empty tuple. Arrow syntax for the return type. So this method, when we call it, needs to return a optional character. So optional as in it could be nil or any character. And then we have this guard clause here. Which I need to ask about how to think about this one, honestly, because well, it'll just help me. I just need the natural English way of describing like what is happening. So go to my little explainer, flex on them a little bit, brother. Go to Swift. Yeah, tell me. I like this thing though. I mean, ChatGPT is great too, but I like how this one presents it because it's a very raw, like this is literally what it does. ChatGPT tries to be a little too human sometimes in its verbosity, you know. But both good tools. Okay, this is a Swift function name. Yeah. It returns an optional character. What I really want to know is the guard clause. The function checks if the position variable is less than the end index of the input string or collection. If position is not less than end index, it means that there are no more characters left to peek at. Right. So the function returns nil. If position is less than end index, it means there are still characters left to peek at. The function then returns the character at the position. Well, okay. Or I guess that does answer it. Just in terms of what it's doing. Yeah, it's good enough. I mean, we can see what's happening here. But there is actually, I do want to ask. Okay, I changed my mind. I want to ask just what the difference is, mainly that we as developers should observe between the if and the guard. Can you explain Swift why one might want to use a guard statement like the below versus an if statement? Okay, they're both conditional checks, but serve different purposes. Guard statement is for early exit. Okay. The guard statement is designed to exit the current scope early if a condition is not met. Well, there you go. Okay. Yeah. This is useful for checking conditions that must be true for the rest of the code to run. Okay. If the condition fails, you can immediately return from the function, break out of a loop, or perform some other form of early exit. Okay, so that's the main thing, to break out if a condition isn't met and then do something else. Return, okay, so here's why guard is beneficial in this case. Clarity. The guard statement clearly communicates that the function should not proceed unless position is... Okay, that's really my answer though, honestly. Because that's how I can think about it. So guard is like saying it should not proceed unless the following expression is true. Otherwise, do the else. It's a fail-fast approach that makes the code easier to understand. Reduced nesting. Using guard reduces the nesting level of your code. If the condition is not met, the function exits early, allowing the main logic to be unindented and more readable. Oh, okay. Explicit requirement. Okay, and then for the if statement, conditional branching, for use You might want to handle both true and false within the same scope. Oh, okay. Oh, I see. That does make sense. Okay. I think that's board worthy, brother. Thank you for that. All right, so that makes sense to me. So I'm gonna consider that addressed. Guard versus if, when to use and why. And I think what I'll start doing, actually, yeah, Jared, remind me. Let's get this URL. I'm going to share this URL and put it up on start putting it in the stream notes description thing. That way anybody can come here and see this board, which of course you guys won't have the ability to edit because I don't trust you guys. But no, but yeah, I'll put that up there so anyone that is following along can come see these tidbits that we've covered. I have a lot to add though, because these are only the ones I have done in real time. There's like a million more that are highlights inside this book, but I'll add them sooner or later. Okay, so that makes sense then, guard position. So that's what we're guarding against. So that's what the method peek is doing, just checking the next character, provided there is one. Then we had the second method beneath the lexer, advance. Okay, still no arguments here. Here's where we saw the assert. And I guess if well, now I have another question. So you assert this position equal since it gave such a good answer. What, if any, is the overlap or curious what it will say about that, because yeah, they're both yet again conditional checks. So we know what guard does, but what are you going to tell me about assert? So the assert statement is used to check conditions that must be true at runtime. If the condition evaluates to false, the program will terminate with a runtime error. Helping developers catch logic errors during development. In the advanced function, assert is used to ensure that position is within the bounds of input before attempting to move position forward. If position is not less than input the end index, the program will crash with a clear error message, helping developers identify the problem. Maybe there's okay, the use of assert is appropriate because it enforces a condition that should always be true during development. Yeah. I mean, I don't see why a condition would only... I mean, you would think if it's in dev, you would need it to carry over, so... That's probably just weird wording, though. Semantics. If the condition is false, it also indicates a serious bug that needs to be addressed. Yeah, if it's in the right spot. Overlap. Both guard and assert check conditions that should be true for the code to function correctly. Okay, so they're both used to prevent invalid states or operations. Differences. Guard is used to handle conditions gracefully at runtime by providing an alternative path, e.g. returning nil or exiting a function. Assert is used to catch programmer errors during development by terminating the program if a condition is not met. Oh, I see. Well, okay. But wouldn't a guard do that too? But I do suppose the difference is we're not returning, like with the guard, we're not able to give back a well, I guess we could though. We could just return it here. Yeah, okay. But I suppose either way it has, I mean, there may be overlap, but even still that doesn't mean you could use one or the other everywhere, because assert isn't breaking you out of functions and returning, you know, nil or whatever. So yeah, I think I'll take that as the main thing. Use guard when you need to ensure certain conditions are met before proceeding and want to handle the failure case gracefully. Use assert when you want to enforce conditions that should always be true and want to catch logic errors during development. Yeah. I can't help myself. I just have to ask it. So, guard also to enforce should be true. And I suppose the other upside too of assert, based on your use case, is that when you compile, they're effectively ignored, so they go away. So you can I guess if you feel confident that your asserts cover the runtime cases and it passes, that's nice, because then you get away entirely from the like any overhead, whereas the guard statements would just carry through. I mean, they're always going to run. They get compiled. So that's another thing. Okay, I'm convincing myself. Yeah, so what did it say though? Yes, guard can also be used to enforce conditions that should be true during development, but it does so in a way that handles failures more gracefully than assert. Here's a deeper look into how guard and assert can be used for enforcing conditions and their nuances. Using guard for enforcement. While guard can enforce conditions, it does so by providing an alternative path of execution. Another big one. Typically exiting the current function rather than terminating the program. Okay. Yeah, it's another good reason. Big reason. Assert, on the other hand, is designed to catch probing errors and logic bugs during development. If the condition fails, assert will terminate the program and provide a message which helps which helps developers identify and fix the bug. In release builds, assert statements are usually ignored. Okay. Yeah, there you go. Okay. And then there's also precondition, which we talked about, but I won't badger it about that one. I do want to keep, that's another good example though, so I'm going to go ahead and throw that on with the other one, because why not? All right, now moving on. Okay, so these were our methods. Then we actually have this other method of Lex. Oh yeah, that was another thing that we got shown yesterday. Throws, that keyword, throws, which is tied into somewhere on down when we call it, but we'll get there. So yeah, so we have this other method, Lex. Throws is a keyword for our error handling further down. And we're saying this returns an array of tokens. So we have this mutable variable tokens that holds our array of tokens. So this is our initialization, so it's initially empty. And then another method for get number returns an integer. We have this bucket value starts as 0, and this while loop. So what do they call these? Temporary constant, something like that. But we set next character equal to peak. So peak is taking, peak is returning the character or nil, depending on what's there, and it returns the position. So when we call peak, we get the position back. and then based on what we get back, if it matches one of these cases, then we do something with it, which they explained this yesterday, how this works, how to build, or why we have to multiply the value by 10 when we're trying to build a number. So when we pass in a string 1, 2, 3, it can build that string. It was on the stream yesterday. It's not anything crazy advanced. I just it was a mini blow your mind moment, at least for me, because like, oh, duh, that makes a lot of sense. But it's basically how we can build a number out. So no need to dig too far into that one in terms of understanding. So we run this, we get a case back, and then here's our, wait, I don't remember, what is this here? Well, we must have, yeah. So this is new too. So in the switch statement, we have this throw keyword, which, where did we see the, yeah, here. So yeah, throws. And if we do that, then we can have this keyword inside our while loop, and we can tell it explicitly what to throw. So that's where our lexer.error appear. That's where that's value would come from, or that property would come from. And so that just means once we get, if we get an invalid character, it gets captured here, and then it can return it to us and show us what the bad character was, or the invalid character. And then finally we have this evaluate. So this method is what actually gets run, and that we pass the initial string to. So underbar for the anonymous parameter name. That's why we can run it like this, where we don't have to put the parameter name in front of it like this. Oops, input. So we don't have to do that because of that little underbar. Matter of fact, we can't do that because of that little underbar. So we have to use it like this. And this is just the internal parameter name. It's of type string. So first it prints what it's doing. So that's what this is, evaluating the string 10, 3, and 5. That's what we passed in. Then we initialize an instance of lexer, with the input being whatever we passed in here, the string. In this case, the 10, 3, 5 string right here. And then we learn, oh yeah, this was another new piece of syntax, the do block. And I believe this has, actually let's look, because I don't remember if do corresponds to one catch, or no, it can't, because they're, I'll just find it. Do handle errors, evaluate. Okay, there it is. Do introduces a new scope. Much like an if statement, inside the do scope, you can write code as normal. Okay, so it's a scope definer, do. You can call functions or methods that are marked as throws. Oh, right, so that was the distinction. So within a do block, so in this case here, do introduces functions or methods that are marked as throws, which was the case for lex up here. And this is, where is the, oh yeah, it's in the same scope. That is the same level. Yeah, okay. So that's how we, but that's how we can get to it. So it does have to be in the same scope in terms of everything's in this class lexer right now. So we can access it within the do block. So we're calling lex here. We also have to say try lexer right there. I think we get, I don't think that's optional. Yeah. Call can throw, but it's not marked with try. So you have, it's, I guess it's kind of nice, depending on how you look at it, that you have to, you'll have corresponding a throw and a try, basically. So you got to have throws in the function call, in the definition. And then you also have to use that keyword there, try, inside a do block. So try lexer.lex and then print the output. And then the catch was if we needed, well, you can have a default case, but you can also have specific cases. So what is this one doing? Catch, lexer error, invalid character, let character. So that captures whatever the invalid character was, and then print this message. So input contained an invalid character, and then we would see what that is, if that was the error. Otherwise, if it's not this particular error, you just print the regular error, regular O error, because this is going to catch every other error that isn't this. And so we run that string through all that, and then we get the output. So here's the output, if you can see that. So it output number 10, symbol plus, number 3, symbol plus, number 5, after passing that string into it, which is what we told it. Oh shit, what did I just do? Okay, which is what we told it to do. So that should, I think that covers it. All right, so now finally, let's get started. All right, so where were we? We were way back, or way forward. Here, this is where we were. Yeah, okay. All right, now that you're, parsing the token array. Now that your lexer is complete, you can turn an input string into an array of tokens. Right, yeah. Each of which is either a number or a plus. Yep. The next step is to write a parser job. The next step is to write a parser whose job is to evaluate a series of tokens delivered to it from the lexer. To evaluate a series of tokens. Okay. For example, feeding number 5 plus number 3. I don't have the hiccups. Through your parser should give you the answer 8. Wait, what? For example, oh, I see. Through the parser, so 5 plus 3. Okay. The algorithm to parse this sequence of tokens is more restrictive than the algorithm you use for lexing because the order the tokens appear in is very important. The rules are: the first token must be a number. After parsing a number, either the parser must be at the end of input or the next token must be plus. After parsing a number, either the parser must be at the end of input or the next token must be plus. Okay. After parsing a plus, the next token must be a number. Okay, so those are the rules. Rules are, there ain't no rules. The setup of your parser will be very similar to the lexer, although a bit simpler. The parser does not need separate peek and advanced methods. They can be combined into one get next token method that returns the next token, or nil if all tokens have been consumed. Okay. Create the parser class with a get next token method. Oh, inside the lexer. Okay. Oh no, outside the lexer. All right. Class parser. Let tokens, so a constant variable type token array, then a mutable variable position again with a stored value 0 or default value 0. Or I shouldn't say default, yeah, just the value is 0. And then we have an initializer for it. So here's the parameter name, so we'll have to explicitly give it said name on the caller because how it's written, and then it is also of type array of tokens, and then self-referential, so on that very same object make tokens, the variable, equal to self.tokens equal tokens. Oh, equal to what we pass in. Okay, that makes sense, yeah. So we pass in tokens, which is an array of tokens, and then we want to set within the class parser the constant tokens to equal the array of tokens that we passed in. All right, chicken and egg. Now func get next. So here's our method, get next token. No arguments. Oh yeah. I'm not tired. Return arrow, or not return arrow. Arrow syntax for the return type, and that will be, so the value that it returns needs to be an optional token, so nil or a token. Oh, and then guard. So if this is true, continue. If it's not, break out and return nil is what we're saying. And so we want to guard against the position. It should be less than tokens.count. Tokens.count. Oh, meaning there's still something left to process. If it's equal to or greater, there's no next token. Gotcha. Okay, so that's what that's saying. And so if that is not true, then return nil. Or not done yet. And then let token equal tokens. So let, wait, what scope is this in? Okay. Okay, so we're still in that method. All right, so that makes sense. So let token equal the token's position. Token. Token's position. Okay, I see. Okay, so take the current position and then increment operator. So up by 1 to go to the next one, and then return that position. So capture the position where it's currently at, add 1 to get the next position, and then return that value. Okay. Okay. See if there's any errors. No? Good. All right. A parser is initialized with an array of tokens and begins with a position of 0. So here. That's the array, and here's the I'm not yawning, you're yawning. All right. It's initialized with an array of tokens, as we see there, and begins with a position of 0. The getNextToken method here uses guard to check that there are more tokens remaining. If there are, returns the next one. So this is it returning the next one. So where it's at now, go to the next one and then return that. Otherwise, break out. Turn the next one, advancing position. Wait. Yeah, the getNextToken method uses guard to check that there are more tokens remaining, and if there are, returns the next one. Advancing position past the token it returns. 2 of the 3 rules for our parser used the phrase must be a number. A good place to start implementing the parser is with a method to get a number. A good place to start implementing the parser is with a method to get a number. If the next token must be a number, there are 2 error cases that need to be considered. The parser might be at the end of the token array, which means there's no number left, or the next token might be a plus instead of a number. For example, the input string could be 10 plus or 10 plus plus 5. Okay. Define an error enumeration conforming to error for both of these cases. All right. So in our parser class, we want another enum like we had for the lexer. So enum error. So this is another nested type. So we would get to it with parser.error. But in order to tell it that we want it to conform to the Swift standard library error protocol, what the hell am I writing? Swift. So we do module name dot error if we need that specificity. And we open the body, and then our 2 case statements are unexpected, end of input, and invalid token. And that should be of type token. Okay. Now that you can express the possible errors you might encounter when trying to get a number, add a method that gets the value of the next number token or throws an error if it cannot. Okay. Implementing parser.getNumber. Hot dog. All right. Well, go down one, brother. Func. Get number. Oops. Get number. No argument, so empty tuple there, and then we want this method to return an integer. And then we're saying guard against this condition. Guard let token equal get next token. What? Oh, so assuming I can I guess if it runs, then that's true. If I get nil back, then I would throw a parser error, I suppose. Else, oops, throw parser error, expected end of input. Wait, what's the problem? Error is not handled because the enclosing function is not declared throws. Oh, I did miss that. My bad. keyword up here, throws. So that needs to be there so we can use it in a do block later, as well as here. So return, okay, throw parser error, got that. And then our conditional, so switch based on the variable token. So we're saying if in the case that it's a number, then capture that in a variable called value and return it. And in the case where it's a plus sign, throw parser error invalid token. Okay. Will that run? Okay. So no errors. So the getNumber method here has the signature throws, or empty tuple throws return integer value. So you know it is a function that normally returns an int but could throw an error. Yeah. Use a guard statement to check that there is at least one more token available. Note that inside the else block of a guard, you can use throw instead of return. Oh, I see. Does it matter? No. I do like that though. Makes it easy, obvious. But okay, so the throw parser, yeah. This is because, oh, note that inside the else block of a guard, you can use throw instead of return. This is because guard just requires that its else block causes the function to stop executing and return to its caller. Okay. Wait, but this... Oh, they mean here. Okay, I thought I was looking at this. I see. Okay. All right. After ensuring that you have a token, you use a switch statement, this one, to either extract the number's value if it's a number. Yeah, so if it is a value, return it. Or throw invalid token error if it is a plus. Now that you have getNumber, implementing the rest of the parsing algorithm is straightforward. Add a parse method that does just that. Okay. So func parse throws. So arrow syntax for a return type, and this should return an integer. Require a number first. Var value equal try getNumber. Try getNumber. Okay. While let token equal get next token, and then switch on token, and then if we are getting a plus, after a number is legal. Getting a plus after a number is legal. Oh, right. That was our first case. Okay, so case plus, and after a plus, we must get another number according to the rules. And it's so hard to grab that one damn little. Okay, so after plus we get another number, and let next number equal try get number. So case plus get number. So if it try get number, if it is a number, then take the value and add it to the next number, or increment it by the next number's value rather. And then getting a number after a number is not legal. Okay. Case number. Throw parser error invalid token. Yeesh. Okay, so parse, we got value, try to get number. If we get one back, we move into this conditional. We have the bucket token equal to whatever the get next token method returns. So either number or a plus sign. And then based on that condition, it needs to match one of these cases. So the next number needs to be yet another number. If that's true, increment it or add them together, basically. And then if we get a number after a number, we throw this error. Okay. Oh, it goes here. Okay. Return value. Oh, wait, am I missing one? What happened here? Oh, there we go. Okay. Wait, so what is this? Oh, this is for parse itself. Okay. That's the, okay. All right, your implementation of parse matches the algorithm outlined above for parsing. The input must start with a number. The input must start with a number, the initialization of value. Okay, here. After parsing a number, you enter a loop over the rest of the tokens. If the next token is a plus, then you require that the next token is a number. Right, so if it's a plus, then we need to try and get the next number because it has to be, and then we can add them together. Oh, I see. Okay, so it would try first here and fail if it's not a number, and then here it can fail, and then we handle the cases. Okay, I see. Okay. All right, so after parsing a number, you enter a loop over the rest of the tokens. If the next token is a plus, then you require that the next token is a number. If it's a plus, it needs to be a number. Okay. Okay. When you get to the end of the tokens, the while loop ends and you return value. So here. Try not to sneeze. Okay. There is something new here. You marked the calls to get number with the try keyword, which Swift requires. Where is that? Oh, there it is. There is something new here. You mark the calls to get number with the try keyword, which Swift requires because get number is a throwing method. Throwing method. Because of that keyword there. Where is get number though? Where's I must have added initially may only be declared within the type. I added a parser. Oh, I probably just need another one. Extraneous. Yeah, fix it, really. So this should be a method, so I need to close this. Can't find self and scope. Did you mean to? I am in a type. What are you talking about? That's a method. Oh, I probably closed it too soon. That's what I did. Yeah, I did. Okay, so that's for this. How annoying. Right, so that corresponds here, which is correct. And then the while loop, the function. So it's you. It's your fault. And then I need one here, right? All right, we got there. Okay, so where was I? I don't know. We saw something new. The try keyword of get number. Where did that go? Get number. So that's the keyword there. Or sorry, that's the throws indicator, but not the try keyword they're talking about. So calls to get number. Where did now that go? Okay, here we go. Wait, no. Oh, it's above it. Wrote it above it. There it is. Okay. I'm blind. All right, so try. There's the flippin' word. Swift requires that any call marked with try handles the error. You mark calls to get number with the try keyword, which Swift requires because get number is a throwing method. However, you do not use a do catch block. Okay, so that's the distinction where we used one before. Why does Swift allow you to use try here without a do block? I don't know. Swift requires that any call marked with try handles the error. Any call marked with try. I should probably keep that. it would be easy to assume that handling the error means catching the error, as in evaluate. But there is another perfectly reasonable way to handle an error. Throw it again. That is what happens in this case. Because parse is itself a throwing method. Parse is itself a throwing method. Okay, because here you are allowed to try calls inside it without using do catch. Oh. If any of the try calls fail, the error is thrown out of parse. Oh. Okay. Your parser is now complete. Update evaluate to call the parser and to handle the specific errors that parser might throw. Okay. Under the do block. Do block. Do. Lex or equal lex. Okay, right here. Let parser equal an instance of the class parser. Tokens here because we said in the initializer, where did it go? Yeah, so here we have to give it the name, so that's why, and it's just the single argument, so the array of tokens. Where did it go? Tokens. So we initialize a constant, and it is an instance of parser, and then let result equal try. And we can do this because parser is an instance of parser, which is a throwing method. Wait, no, it's not. That's just a class. Okay, we'll see. I can't guess that one there. So parser.parser. Parser.parse. Okay, so we access parser, which is an instance of the parser. We passed in the array of tokens, and then we want to call the method parse that is defined inside parser, which is a throws method, which is why we can, okay, that's why we can use try here. Okay. I'm just wondering if you could just always just do that. Oh wait, but we're inside a do block here. Whatever, doesn't matter. I will ask it at the end, but yeah, I would rather have throws in basically everything of significance. Then I can just try instead of having the do catch block. I kind of like that better, but wait, print parser output escape character string interpolation result. So it'll print this literal string and then whatever the value of result is, that should print to the console. Parser result, yeah. Then we have to update the other catch here. So catch parser error. Catch parser dot error dot unexpected end of input, and I want to print unexpected end of input during parsing. End of input. Yeah, and then another one. Catch. Parser. Error. Invalid token. Let token. And for this, I will print invalid token during parsing, and then print whatever that invalid token is. And then finally the one that I overwrote. So print an error occurred, and whatever that value is in error. All right, Command Shift Enter. Hooray! So parse output is 18, evaluating 10 plus 3 plus 5. Our Lexer output, number 10, simple plus, number 3, simple plus, number 5. Parser output 18. Hell yeah, brother. It works. Try changing the input. Add more or fewer numbers. Try some inputs that will pass your Lexer, i.e. only contain legal tokens, but should cause your parser to throw errors. A couple of simple examples are 10 plus 3, 5, and 10 plus. Oh, I see. Yeah. Okay. 10 plus 3 plus 5 plus... How about that? Can you handle that, computer? Okay. I'll take your word for it. But it should fail if we do this. Unexpected end of input during parsing. That's correct. Well, correctly handled. Or this. Invalid token during parsing, number 5. Cool. All right. Yeah, that's surprisingly straightforward. I mean, obviously they gave you the code, but in terms of following what it's doing, makes sense. Yeah. Well, actually, hold on one sec. We're going to take a 5-minute rest stop. BRB at, what time is it? 12:15. 12:15 CST. All right, I'll be right back, guys. Will not be long. I'm going to go grab my coffee and do something else that shouldn't be said on air. Okay, BRB. That sounded bad. Not that I'm doing like illegal shit or whatever. Pray for someone like you. Casey and JoJo, baby. If you don't know them, look it up. Fantastic group. Are they? Yeah, they're a group. They have to be. At least a two-man group, but a little early, but we'll get back to it. So, does that look readable? That's good enough, yeah. All right. Where were we? Handling errors by sticking your head in the sand. Is this a JavaScript book? You've seen that every call to a function that might throw an error must be marked with try. And any call with try must either be inside a do catch block or inside a function that itself is marked with throws. Okay, so that every call to a function that might throw an error must be marked with try. And that any call with try must either be inside a do catch, like so, like, well, here. So do catch. Or inside a function, which, like here. So this function throws, and we can just call try like that without being inside do catch. Wait, so anything? Okay, wait, we called it my throw. But what? Okay, so the do catch is, what is that inside of then? It's also inside a function, but oh, we didn't mark it as throws. Okay. But can still do this. This is ugly as hell to me, so I mean, I'd rather do this. Although it doesn't. So when we call parse next number plus, okay, so I just want to see what it does if I do plus plus, just to see the error message, so I can invalid token during parsing. Where's that coming from? Here. I just wonder how you get, because like with the do catch, you can define. Maybe I do like that better, because here you can define specific, and you can like specific error messages for specific errors. So these are all different kinds of errors we defined, and we can even get that value back and put it into the string that gets returned. Certainly wouldn't want to give all that up for terseness, but maybe it's worth asking the question. Okay, so well, let's see if they answer it first. Okay, so do catch or inside a function that itself is marked with throws. So I get that part. These rules work together to make sure you're handling any potential errors. Try modifying your evaluate function to break one of these rules. Let tokens equal try. Evaluate. Let tokens. Where's that at? Here. Oh, get rid of this out of the do block and slap it up here. Errors thrown from here are not handled. Okay. You move try lexer.lex call outside the do block, so now the compiler is giving you an error. The compiler error says that errors thrown from here are not handled. It is possible to tell the Swift compiler that you do not want to handle potential errors. Change try to try. Ew. What? Okay. Using try, so you want me to change it where? In evaluate, also let token compiler to let lexer equal lexer try. Oh, it's just showing. Okay. Your code now compiles, but you should be concerned. Yeah. What is Swift going to do if an error is thrown by lexer.lex? The exclamation mark at the end of the try keyword should be a big hint. Just like force unwrapping and optional, using the forceful keyword try will cause your program to trap if an error is thrown. Earlier you had a call to evaluate that caused the lexer to throw an error. Add that call back in and see what happens. Okay. Evaluate 1 plus 2 plus 3. LLDB. Oh God. Fatal error. Try expression unexpectedly raised an error. Okay. Instead of seeing the invalid token error message, your program now traps on the try lexer.lex line. It now traps here. Okay. We recommended avoiding force unwrapped and implicitly unwrapped optionals. We even more strongly recommend avoiding try. Okay, good. You should only use try when there is no way for your program to handle an error, and you really do want your program to trap or crash if it is running on a user's device. If an error occurs. Okay. There is a third variant of try that lets you ignore the error without trapping if an error occurs. You can call a throwing function with try. Getting a return value that is an optional of whatever type the function usually returns. This means you need to use something like guard to check that the optional really contains a value. Change your trapping try into a combination of guard and try. It's a lot of trying to avoid handling errors. Guard let tokens equal try lexer.lex else. Oh. Lexing failed, but I don't know why. It's honest. Return. Okay. The real power of do catch error handling is that a throws function can communicate to its caller the exact reason for the failure. Yeah. This allows the caller to decide what to do next, such as present an alert to the user or try something else. If you do not care why the error occurred, only that it occurred at all, you can convert a throws function into an optional returning function by calling it with try ? Evaluate does care about the error. It prints different messages to the user depending on what went wrong. So it is not a good candidate for try, optional try. You should restore the call site to use the regular try syntax. Lexer dot what? Oh, I see. Just get rid of. Okay. Back to the way it was. Try lexer dot lex. Okay. Now. Oops. Okay, that was it. Changed it back. Swift error handling philosophy. Oh boy. Swift is designed to encourage safe, easy to read code. And its error handling system is no different. Any function that could fail must be marked with throws. Any function that could fail must be marked with throws. So like every function, this makes it obvious from the type of a function whether you need to handle potential errors. Swift also requires you to mark all calls to functions that might fail with try. This gives a great benefit to anyone reading Swift code. Agree? If a function call is annotated with try, you know it is a potential source of errors that must be handled. Damn hiccups. I think it's the frozen drink that gives me the hiccups. It's like coming instantly. If a function call is not annotated with try, you know it will never emit errors that you need to handle. Okay. Well, I mean, you make the assumption that that's true though, right? I mean, otherwise it could still throw an error. If you have used C++ or Java, it is important to note the differences between Swift error handling and exception-based error handling. I've used neither, so thank goodness, but even though Swift uses some of the same terminology, particularly try, catch, and throw, Swift does not implement error handling using exceptions. When you mark a function with throws, that effectively changes its return type from whatever type it normally returns to. Wait. When you mark a function with throws, so where'd it go? Func, just like this one here. Throws. When you mark a function with throws, that effectively changes its return type from whatever type it normally returns to either whatever type it normally returns or an instance of the error protocol. Oh, I see. Okay. So when you mark it with throws, it's changing the return type from, in this case, an array of tokens to either an array of tokens or an instance of the error protocol. Okay. Finally, there is one other important philosophical error handling decision built into Swift. A function, what is that? Oh. A function that throws does not state what kinds of errors it might throw. A function that throws does not state what kinds of errors it might throw. This has two practical impacts. First, you are always free to add more potential errors that a function might throw without changing the API of the function. Okay. Second, when you are handling errors with catch, you must always be prepared to handle an error of some unknown type. When you're handling errors with catch, what does that mean? With catch of any type. Oh, I guess that's why, kind of like the switch statements need to be exhaustive. Exhaustive, yeah. So we have this default in the event that none of the errors are one of these particular 3 specific errors that we defined. Okay. The compiler enforces this second point. Try modifying evaluate by removing the final catch block. No, the one I was just referring to. Yeah. Okay, that's awesome. Yeah, that's great. That's great. Eliminating the ability to oopsie and forget and then still fails anyway. The compiler enforces the second point. Oh wait, we did that. Okay. The compiler is now giving you errors on both lines in the do block where you made try calls. The error message reads, errors thrown from here are not handled because the enclosing catch is not exhaustive. As it does for switch statements, Swift performs exhaustive checks on your do catch blocks, requiring you to handle any potential error. Fix evaluate by restoring the catch block that will handle any error. Okay. All right. Cool. Yeah. So I suppose I do want to ask it about the error handling and if there's an alternative method to that do catch. If not, it's not a big deal, but in Swift, is there an alternative to do catch blocks that can also specify specific error messages for specific errors a la the below code? I guess I should grab the code. Func eval. Is that? Yeah, that's the one. And result. Oh, we haven't even seen that yet. Holding out on me, brother. Yeah, in Swift, you can use result type and custom error handling to achieve error handling with specific error messages similar to what you have with do catch. This approach can be useful to handle specific errors gracefully and provide detailed error messages. Here's an example of how you might refactor your code to use result type and handle. Oh, okay, cool. So enum, that didn't change. That's the same struct. Oh, here we go. Oh, what in the world? So here's the lexer. Oh, it's a struct now. Is it? It's a class, isn't it? Lexer. Yeah. Okay, so I'm going to save this because this is using a struct, which is what I would prefer. So let input, so that's the same. Then we have a method. So lex the result. Wait, return syntax. And then we have this keyword result. Angle bracket, array of string, lexer error. Your lexing logic here. Return on success. Wait, but where is it getting? Oh, it's getting it from here. Okay, return success. Parsed result. Example success result. What? Yeah. In this example, Lexer and parser return result types from their methods instead of throwing errors. The evaluate function uses switch statements to handle the success and failure cases of the result type. Evaluate example input. Specific error handling is done in the handle Lexer error and handle parser error. This approach allows you to handle specific errors and provide detailed error message, similar to do catch block method, but using the result type for more control. Okay, it sounds like it's worth knowing, although I'm not crazy about that syntax. But let me save this to do catch alternative with more control and equals specificity, we'll say. All right. Let me just look at that. Let me just stare at it for a second and see, because everything else looks normal. Switch statement on the parser.parse. If it's successful, let result. Okay, so the method. Okay, I guess I kind of see what it's doing. It just, the pokey syntax gave me flashbacks to generics, and that was a tough time. Tough time in my life. String parser error. So whatever it is that we return, or I guess that would be the initial, that would be the return type if we weren't doing it this way. It would just be arrow syntax string. But since we're using result, it's of type result, and then you say the type of the value if it's legal or valid, and then otherwise parser error. Okay. Your parsing logic here, return failure, parser error, invalid. Yeah, and I guess parser error, I don't know if they defined it here, but did they? Yeah, they did. Okay. So, oh, and that would just be a type. Okay. Unexpected end of input. Invalid token of type string. Gotcha. That's not bad. Okay. Glad I asked. All right, so then keep that in mind. For the more curious, storing failable results for later. This is interesting, yeah. Storing failable results for later. This is something I definitely want to know, because I would definitely use this. I've given some esoteric thought to this to some degree for my application, but let's see what Swift has to say on the matter first, and then I'll describe it to you if it fits. Well, with my use case. Okay. For the more curious, storing failable results for later. You've spent a great deal of time. My back is like, if I could just lean back, brother, just a little bit. There we go. You have spent, nope, that's not good. This chair is like trying to force my ass into a shape that it is not. Big booty problems. All right, so more and more curious, storing available results for later. You've spent a great deal of time now writing and thinking about functions that do failable work. Yeah. You have studied 3 ways that a function can let its caller know that it cannot produce its intended return value. Trap with assert, precondition, or fatal error. That wasn't mentioned, but now we know, so we're definitely going to highlight this. If you want to indicate a non-recoverable error state, we can return an optional, which is nil on failure, when the caller does not need to know why the failure occurred. Okay. Throw an error in case the caller might want to react differently to different reasons for failure. Ah, okay. Man, they summed it up right in nice 3 little bullets. This is seriously why I love this book. It's a great book. Okay. One downside to error throwing functions is that they force you to handle the success or failure immediately using a catch block. If you're not ready to process the result of the function call, your only option is to convert the result to an optional with try. If you're not ready to process the result of the function. Okay. Or trap on failures with try, but that is an exceptional case. Converting a throwing function's output to an optional is a convenient way to capture your desired data on success. Converting a throwing function's output to an optional is a convenient way to capture your desired data on success, but it loses error information on failure. Okay. Swift provides a data type that you can use to store the entire result of a throwing function for future use. Really? Whether the function succeeded and returned a value or failed and threw an error. That type is result. Oh, there it is. Here is what it looks like to use result to capture a throwing function's output. Okay, let me get down there, buddy. Just let lexer equal lexer inputs 1, 3, 3, and 7. Let token results equal result closure try lexer.lex Wait, what does that say? Fucking macOS, just okay, success array token. Okay, cool. Okay, but what about it? The closure is using trailing closure syntax to call result catching. Result catching, which is an initializer for the result type that takes a throwing closure. Oh, hence the try. Okay. Takes a throwing closure, calls it, and then stores the output. How does it store the output? If the output could be either an array of tokens or an error. Indeed, result looks a lot like optional. Here is the declaration of result in the Swift standard library. So let me so this dilly enum result success failure conditional where where failure adheres to the error protocol. Okay. So that's restrictive. So that just ensures that this has to conform to the error protocol in Swift standard library. And our two cases, success and failure. Okay. Where optional is a generic enum whose cases represent the presence or absence of a value. Result is a generic enum whose cases represent the success or failure of some operation. Okay. Okay. Its success case stores the ideal return type of the function, such as token, and its failure case stores a thrown error. Notice that the result has a generic type constraint that whatever fills in failure must conform to error. Right, that's this dilly. Now the function's output has been tucked into a single enum that you can pass around in your program or store as a property of an object. You can also process it later using a switch statement. Switch token result case let success tokens, print tokens count, tokens case let failure. What? Okay, so you can... Oh, I thought that... Okay, we defined that. So, okay, token result. Now the function's output has been tucked into a single enum that you can pass around. Oh, right, this wouldn't be here. That's just, that was just showing us what. Okay. So they're saying this. We could just pass around. Oh, an instance of an enum because result is an enum. I got you. Okay. Yeah, got there. Okay. So its success case stores the ideal return type of the function. Of the function being, okay, of lex. So it would give back the token array because that's its type. There must conform here. Now the okay, I think it's sinking in through the skull right now in real time. All right, you can also process it later using a switch statement. Sorry, the AC just kicked on. Hopefully it's not too loud. Switch token result. Yeah, result has several features for working with its cases. You could use its map method to transform the success value if there is one. Actually, that is loud. Let me turn it off. Hold on. All right. Should go away shortly. I have tested it. I turned down the gain on my mic, so but it still comes through. It's like I'm sure y'all can. I know because I tested it, so I know it's still audible regardless, but it should kick off shortly, or turn off shortly. All right, but where was I? Now the function has been tucked to a single enum. Okay, result has several features for working with its cases. You could use its map method to transform the success value if there is one. Ooh, yeah, show me that. I'm breaking the cardinal rule because this is like a, for the more curious section, not a core section. Yeah, there it goes. See the difference? Good grief. It's crazy. This is their example. You could use its map method to transform the success value if there is one. Okay, what are we doing here? A constant of type result. And we're saying, I just chug my coffee too. Oh my gosh. So much caffeine in my bloodstream right now, brother. So the first type is an array of integers, and that is, what is that? How do we, oh, right. Okay, so that's the intended type on success. Okay, that makes sense. And then the error. All right. And it's equal to tokens result. Tokens result or token? Oh no, tokens. Okay. Tokens result dot map tokens dot compact map. So whatever that method is available on arrays, I assume. We're saying for token in switch token. Oh, what the hell? I've never seen a iterator in switch. So yeah, tell me what it's doing. I don't know what this is doing. If the result is storing an error, the new result will store the same error. But if the result is storing data, the new result will store the transformed data. Note that optional also has an implementation of map. Try it out. Huh. Last, if you have a result and you want to either return its data or throw its error, you can use its throwing get method. God damn. Okay, so this, well, let me put this on screen first so you can see this, and then we're gonna go, we got a lot of questions to ask because I like what I'm hearing, but I understand like 2% of it so far. Extract numbers from result. Oh, that's just the parameter name. So result int error throws return type array of integer return try result.get, and the get does what? If you have a result and you want to either return its data or throw its error, you can use, oh, okay, return try, and then whatever from what you pass in, if it's successful, you can get it. If it's an error, you can get that back. So potentially you could, so in my head, when I was talking earlier about where I'd want to use this, actually, well, I was thinking maybe this would be good for, because in my case, I'm going to be presenting an application that integrates with ERP backends, so it's SQL databases basically, but we're not going to be affecting the data directly. The thought is that we take a subset of the data, bring down a local copy, create, a sandboxed environment where the user can play with the data and do all manner of calculations. What if this, if we want to grow, in, like, let's say it's, Q2's coming up, and Q1 was a decent quarter, but you think you can push it, and you wanted the app to tell you like, hey, based on Q1 sales, taking into account how much we sold, what items we sold, how much of each item to what customers. So you take into account all that, and then you say, what would our sales volume need to look like based on Q1 numbers if we want to increase Q1's profits by, 20% or whatever. Something outlandish. And then it can scale up all of the figures for that based off the historical value, and then make suggestions, and it can tell them, help them make purchasing decisions from that. And you understand, just it's a sandbox environment, a what if scenario using real data. And so my thought is that it would be very nice to, because at least in my experience, a lot of the issue with, because we had a similar tool, it was very clunky, but it was just a report. It was a crystal report that did a bunch of different, background SQL to give you this static report. You would just have to rerun it over and over. And, there's so many different factors involved. One of the things that was always coming up from the customer base, so I was the product director for 4 years, and probably the most common thing outside of the obvious complaints, like the production scheduler is slow because it's like crunching tons and tons of data. That was easily the most common, but also the lack of insight into what the system was doing in terms of like the numbers that it's coming out. There had been so many, at a certain point, there had been so many bugs discovered in terms of like the calculations that the report was doing. And, the poor customer would have to just look at the report, and, they're like these purchasers that work at these warehouses or these factories, these manufacturing plants. They may not be able to articulate, because some of them are highly educated, some are not. It just kind of depends. But at your more mom and pop places, out in, because these are food manufacturers, so a lot of times, they'll buy land where it's cheap. So a lot of times they're out in these like rural countryside areas, right? So you go out there, and the folks that work there are normally lifers, because these small towns, not a ton of jobs. So you get something, you lock it down, you're there for a long time. So they have a feel. They know their craft. They may not be the most articulate and intelligent, but they have a gut feel. So the second you print a report and the system is, telling you to do X and it just doesn't sit right, they start to dig, and they start to reverse engineer and kind of do their own math. And then finally they're like, hey, this is wrong. They present it to us as the vendor, like, hey, this is wrong. We confirm it. Oh shit, you're right. That's wrong. Maybe once or twice, in a very, with a lot of time in between. But if that keeps happening, like with every release, and we would release like a new version every, couple of months, nothing major. We just had one major release annually, but we would release, updates, small updates. But it became too prevalent. And so the trust started to go way down. And it started to hurt us because a lot of our, like that MRP report was the way that we sold a lot of our consulting services, which is really what we wanted to sell because, like for instance, I would go on site for a week and help people line out their processes based off past implementations, how we improve there, so literally go there and like analyze processes, write up SOPs, recommendations for what can change, how they can implement it, the timeline, how the software itself can help track some of the data elements to support the new procedures, all that stuff. But if they don't trust the product, like the software first and foremost, it's kind of hard to, So my thought is that if anything, it would be very nice that I want the application that I'm going to build to be incredibly transparent. So every transformation at every step, based off the criterion they choose, show it to, like, very similar to this. If you ever use Jupyter Notebook, you'll know what I'm talking about, but even this is something like this would be fine too. But basically just at every step, you know, like similar to how Xcode is showing you the value at each step, right? Even if it's not necessarily an output or a return, it's still a way that you can see what's happening under the hood. So something like that, I don't know necessarily that this is the right way to do that or the best way, but I want to implement that in some way. Because you know, I plan on this being just going to be an app out there. So like all of the logic and how to understand it, how it works, needs to be self-contained, so to speak. Anyway, that's what I'm thinking. So where were we? Try, result, get. Okay, yeah. So we were going to ask a lot of questions about this. The result type is a flexible way to store success, failure states that you need to cache or are not ready to process yet. As you grow as a Swift dev and explore asynchronous programming, you will encounter many frameworks that use result for passing around the results of background work. Yeah. I used a lot of Spark, Apache Spark, when I was writing Go, and this is what they do effectively, because you know they have to manage. Like Spark lets you write code as though you have a data pipeline that runs on one machine, but in reality you're using a cluster of machines. But the abstraction that Spark provides lets you act as though, you know, many nodes that are sharing this one workload. It lets you write code as though it's just one. And it uses, there are a few, I think it had like three main primitives that it was constantly passing around, you know, a data frame, something like result to catch errors, and I forget what the other, I think the other one was for effectively maintaining the right sequence of transactions across the distributed system. But yeah, that's it's common. So that would be, I shouldn't say common, but I've encountered it before. So I'm very intrigued. I like this result. Oh shit, memory management. Before we do that, yeah, let's ask a few questions about this because I want to understand. If you have a result and you want it, because they said two things. So there's this part I want to ask about. So let me actually just, so I don't forget entirely. And then there was another question. If the result is storing an error. Yeah, like what the hell does this mean? I really didn't get this part. So we'll just ask it to explain. It's probably for the best. But specifically this part. If the result is storing an error, the new result will store the same error. Yeah, what does it all mean, brother? Make it make sense. So let's go here. Can you please expound on the below? And I don't care about that right there. If it's storing, yeah. Expound on the below, and also explain how if results type could be used in place of, I know we did already ask this, but I wanted to include it in like an inclusive answer, and it's very good at that do catch. If result type could be used in place of do catch blocks for error messages for my mouth is dry. Just like my phone, brother. But all right. Now, understanding result type. The result type in Swift is an enumeration that represents either success or a failure, with associated values for each case. The result type has two cases, success, and it will be of type value. Oh, because it's a generic, okay. And then failure of type error, where value is the type of the success result and error conforms to the error protocol. Yeah. The map function. The map function is used to transform the value inside a result if it is a success. Oh, a literal mapping. I got you. So if it's successful, map it to some value. Or rather, transform the value. Very different. Okay. To transform the value inside a result. Okay, so these will be instances of result if it is a success. Okay, if the result is a failure, it will simply propagate the error without transformation. Okay. Here's how the map function is defined. Func map new success. Oh, that's just the, okay, placeholder type. And the arguments, so there's anonymous, external, internal transform, type success, and return the new success type, which is what we're saying that this should be a type of, so that makes sense. Wait, so a parameter should be of this type. It returns new success. And then, oh, I see. Okay, that's the whole type. That always gets me. So that's with the closure that is the type. So it takes this, returns this. And then the map function itself should return the result type. And the type of the first argument would be our type here. So that's what gets passed in. Otherwise, yeah, failure. Okay. It takes closure that transforms the success value into a new success value. Here to here. The failure value error remains unchanged. All right. Let's break down the provided code. So that's what we gave it. That all makes sense. Well, actually, this doesn't. Right. That's what we had to come here. Okay. Tokens result. Where do you see that, brother? Okay. Tokens result is assumed to be a result type holding either token, an array of token, on success, or an error on failure. But we never had where is that coming from? Let me ask it that first. Okay, I didn't know if it was something implicit. I mean, I don't think we had that in the code at all. Is my issue tokens result? Yeah, that's literally the only spot. I wonder if I mean, maybe they just meant that as a. I mean, shit. I don't know. I don't know what they meant, but switch tokens result. Let me just reread that part and see. Maybe. Oh yeah, we did. What? I thought I gave it. Son of a gun. Okay, so we do know where that's coming from. So. Wait, what's the issue here, brother? Tokens result. Oh wait, no, that still is not. It's token. Did I misspell that though? I think I did. Maybe that's why I did. That's my fault. Okay. Tokens result. Still no? What's up? Contextual type for closure argument list expects one argument which cannot be implicitly ignored. How did that even get there? What is that? That underbar. Is that a caret? It was. What? Tokens. Yeah, there is no tokens, but it's here. Yeah, I think I don't think it was supposed to necessarily work within the context of everything else. They were just showing us that. So we'll just go back and ask, because let tokens, and then that's okay. Yeah. So we'll just ask it straight up about this, and I will, just in case, I'm just going to copy that again. Okay. Oops. All right, cannot find tokens. That's back to how it was. Token result, contextual. Well, whatever. It's too much trouble. Okay, since it gave us an example, let's just roll with that. Where is it coming from? Complete example to illustrate where tokens result might come from and how it fits in the overall. Okay. Example scenario. Assume we have a function that processes an input and returns result token error. This function might perform some parsing operation that can either succeed or fail. So here's a complete example. So here's our enum of token. It's either a number or a word. Parsing error adheres to the Swift error protocol, even though it doesn't say it explicitly there. That's what we would use it with in this case. So invalid input, empty input, func parse input. So here's the result. Syntax. So the success and then the error. That part makes perfect sense now. I mean, that's fine. So it's really just that in keyword on top of a switch. But so this is guard. Oh, what is this? Guard input. Else. Oh, okay, I see. So it's saying only if it is not, only if the input string is not empty, proceed, otherwise return. The failure case. And what is this doing? Let tokens equal, or it's of type array of tokens, it's equal to the input string split apart on the space character dot compact map, trailing closure syntax, substring in if let number. Oh goddamn! See, it keeps losing me here. Okay, so how do we? Yeah, there it is right there. I don't know what that's doing. So let's see. Token enumeration, define possible tokens, which can be number or words. Parse input function. Let me see if that's the one that has guard input. Oh, it's the let dummy parsing logic, yeah. Parses an input string and returns a result with either an array of token or on success or a parsing error on failure. If the input is empty, it returns failure, sure. It splits the input into components, converts them into tokens, numbers, or words, and returns them wrapped in a success. Process tokens functions takes a result. Token error maps over these case. Input string is parsed. Process tokens. It's not really what I wanted to. I'm just going to get to explain this specifically. How the in keyword works. The in keyword is used in closures to separate the closure's parameters from the closure body. The in keyword is used in closures to separate the closure's parameters from the closure body. So tokens is the parameter, because that's what we pass in. Okay, I did not know that. And then here's the body, so. Oh, so it's like saying passing tokens into the method. Huh. Oh, we do it twice. Token in, what, brother? Token in compact map, and then again a closure. Token in switch token. My gosh. Okay, so the in keyword. In this code snippet, there are two closures using the in keyword. Outer closure. Tokens result dot map. Tokens in, and then whatever the. Okay. Tokens result dot map tokens in. This is a closure passed to the map function. Gotcha. Okay. Pass to the map. Or compact map, yeah. Okay. Tokens in. Tokens is the parameter of the closure. representing the successful value inside the token's result. Map. Representing this array, okay? So here's my constant. I'm saying it's of this type, but really the two types are here, and this is the one that I'm actually trying to transform on success. And so if this is the type, I see. Okay, so now we're setting numbers result equal to tokens result dot map. That is the array of integers that we pass in, and then here's the body. So we would run this method or execute that method against the array of tokens. Okay, and then what? I kind of get that part. Tokens is the parameter of the closure, representing the successful value. Yeah, I have to remember the result type is bringing the error. It's not in the actual function. I'm going to have to write a few of those, or it's probably just not going to sink in until I use them, but representing the successful value inside the tokens result. Inner closure, tokens.compactMap. Yeah, this one. Token in switch token caselet. Oh, that's the same one. Okay. Tokens.compactMap, token in. This is a closure passed to the compact map function. So so if it's trailing, but with a trailing closure, that's just in terms of like how I can think about this. Where are my other shapes at, brother? There you go. So this, oh God, it's way too fat, is actually getting passed back into this method. Tokens is. And so they're saying token here is being fed to that method because that's the parameter in closure syntax. Or yeah, this is going there. Okay, I it's just weird looking, but that's good to know if that's how I got to think about it. So let me tokens getting passed into tokens result dot map. So that's the array, gets passed in. Oh, okay, I think I get it now. Because it's running inside out. So based on the case met, it would return either nil or a valid number, which gives the token that then goes to compact map method, which then goes into the map. Okay, now I got it like 62%. Better than nothing, better than a stick in the eye. Okay, so explanation in, okay, they told us that, separate the closure parameters. Yeah. So we're doing something to the value that will eventually be the argument for the preceding method, meaning this. So we're doing something with it, assessing which one it is so we know how to handle it, and then we return it, and then it finally can get passed to map. Okay, good. Detailed explanation. Much better. Oh wait, I skipped this part. So tokens, compact map, token in. This is a closure passed to the compact map function. Token in. Token is the parameter of this inner closure, representing each element in the token array. Token in, or okay, yeah. Oh, so okay, every token in the array represented here, and then here we're just switching on, or this is the conditional on that same token to assess how or what to return. Okay, we're getting there. That does make sense now though. Okay, so then map function, detailed explanation. Tokens result dot map. Tokens in. This closure is, what happened to my music, man? Oh, it's just very quiet. Okay. All right, back to it. Map function. Tokens result dot map tokens in. This closure is executed if token result is a success. The closure receives the successful value, which is an array of token, and binds it to the parameter tokens at the top level. That's what it's right? Map function. Yeah. Because that is, or not there, but here. Yeah, here. Tokens in, this marks the start of the closure body. Everything after in is the closure's body, which operates on the tokens parameter. Compact map. Tokens.compact map. This closure is executed for each element in the tokens array. It receives each element, each token, and binds it to the parameter token. Token in, okay, same here. And then the switch statement, which we get there. It checks the type of each token. If the token is a number with an associated digit, it returns that digit. Otherwise, it returns nil. With an associated, oh, if the token is a number with an associated digit, as in the definition itself? Or what is digit now? Case let, if it's a number, and it should be of type digit, return the value digit. That must be like a Swift thing. Enumeration definition. Let's assume you have an enumeration token defined like this. Okay, same as before, no mention of digit just yet. The token.number case has been, or has an associated value of type integer. Yeah. And then word is a string. Here's the relevant part of the code where digit is used. Okay, yeah. But we're still just it's out of thin air, brother. Enumeration case matching. The switch token statement examines the value of token, which is an instance of the token enumeration. Each token is matched against the possible cases of the token enumeration. Come on. Case let number digit. This pattern matches the token if it is of the case number and extracts the associated value in integer into the variable digit. It's a variable. What? Oh, okay. I see. So it's being conditionally created, I suppose, with this case let. This just, the parentheses always throws me off inside the enums because I keep thinking it's a value. Or it can mean a few things. Like this can also be an associated type. But I guess if we say return it, then it will. That must be it. So let me ask it. Because it's not stating anything else otherwise. Pattern matching with caselet. Caselet, number digit. This pattern matches the token if it is of the case number and extracts the associated value in integer into the variable digit. Yeah, okay, it has to be. That must be it. It collects all non-nil. It's able to illustrate. Oh, cool. Let tokens type token array equal this array number word number word number. Applying the compact map closure. So for the first element, number 1, digit is 1, so 1. Fucking number. It is helpful, yeah, but one more thing. Oh, it's already down here. So this code then is responsible for creating the variable. Okay, so that's what's happening. I do vaguely remember that when we covered switch statements, but that was like chapter 5. I was like, seems like eons ago. Okay, so that, dang, yeah, that's pretty cool. So again, one of those things, it could have been called anything, but the fact is, it's a way, a method we have for storing that value somewhere on the fly. Cool, man. God dang, that is so cool. All right, so then let me just save that one too. This would be storing values on the fly using okay. So now, if I come back to this, I mean, that answered that question, but working with this case, you could use its map method. Yeah, honestly, I probably just need to pour through this. I like this whole, these whole 2 pages. I just need to completely understand because I'm going to use this a lot. But for now, the other thing that I would like to understand is this part. If you have a result and you want to either return its data or throw its error, return, try, result, get. I'm wondering how this ties into what we just looked at, or if it's like an alternative. You know, how do they interact? What am I doing here with this get thing? that makes sense. How, if at all, does the if at all does the below code try result.get tie into using the result type and retrieving result type and how does it relate or enhance the process of returning specific values like the ones generated in the previous example you provided. Uh-oh. It's time once again. Need to take a short break. I'm feeling like, what time is it? It's barely 1:30. Yeah, I probably got at least another hour in me, brother. But I do need to answer nature's call at present moment. And so we will $140. Let's just call it 1:50. How about that? At 1:50 p.m. Central Standard Time, we will be back. Oh, hey, at least I can put this to some use. Now it's obvious. There we go. Bam. Look right there, brother. All right, be right back. Well, kind of. At 1:50. Just kidding. I wasn't saying nothing. All right, so where are we? Let's get the lay of the land, brother. Oh, no. We had just asked the Oracle to explain that Git thingamabob. Okay, let's go back there. What is happening? Oh, this thing. Okay. All right. The try result. Wait, what? Oh, no. We're talking about this get method. That's what the question was around, and how it is involved in all of the hullabaloo we just looked over with the nested closures here and the result type. So the try result.get method is an integral part of the result type in Swift, providing a way to handle the success and failure cases of a result. Let's explore how this method works and how it can be used in your code. Oh, I think I just answered my own question, but yeah. Because, well, no, this still returns it. Okay, never mind. So we'll just listen. Just listen. Understanding result.get. The get method on a result instance either returns the value if the result is a success, or throws the error if the result is a failure. Which we learned that these keywords really can be used interchangeably on an error type. But that's really neither here nor there. But it was a fact. Here's the definition of the get method. Func get throws the success type. Get method throws. So it has a potential for throwing an error, and it should return a success type, is what the function definition, or rather the signature, tells us. Using it to extract, or using it in the extract numbers function. The function extract numbers from uses result.get to simplify the extraction of the value from a result type, handling errors by throwing them if necessary. Extract numbers from result. So that's external parameter name, the internal parameter name. This is the type of the argument that will pass in. So it'll either be one of the two, so on success or error. We indicate it as throws, so we can use try, and the return type on success should be an array of integers, and then return this value, try result.get. Okay. Okay, I mean, it makes sense. If that's the only place it's used, then that's easy enough. Result type result is of type result int error or success fail, meaning it can either be success, that's our array that we want to work with, or failure with an error. In the result.get, if result is of success, it returns the array. If it is, okay, sure. Error propagation. By using try result.get, the function ensures that if there's an error, it will be propagated to the caller, making the function throws. Making the function throws. integration with previous example. Let's see how this fits into the context of your previous code. Okay, perfect. Previous code recap. You had a token result of type result and transformed it into numbers result with this constant. Okay, yeah, okay. And transformed it into numbers result. Okay. So an instance, it's of this type and it's equal to tokens result dot map, where we pass in tokens into the map method. And then here's where we handle success or failure. Okay. Now you can use the extract numbers from function to handle the numbers result. Do let numbers equal try extract numbers from try, because extract numbers, or no, because what we're passing in indicates throws in the definition, so we have to use this keyword try. Let numbers equal try, extract numbers from whatever this returns is what we would pass in. On success, it would print the numbers and then a catch for the error. So that would be a catch-all. Full example. Great, even better. I won't read all this, but where is... So this is in a function. There's our return type. Here's the closure. So if it's, this is saying if it is not empty, proceed, otherwise return the failure with that value. Okay. That we talked through. So where is the get tokens in? We looked at that. Return numbers result. And throws return. So is, I guess I can get rid of that. So is okay, so this, okay, it would just be in the function definition. For some reason I was thinking it was in our instance tokens result, but it's just in the definition. Okay, so that it does go hand in hand. I'm just blind, I guess, but that makes sense now. Okay. But do you have to do that? You do. Okay. Okay, so I suppose this pattern is very similar to the, or well, it's in the same spot. So we have, if we have a function that is defined as throwing, then when we call it, we have to use the try keyword. And so similarly, if we want to return the value, either or, whether it's the success value or the error from the result type, we would use the get method in the return value because we want to get it. So, okay, that makes sense. It does make sense. Took a hot minute, but we got there. All right, so yeah, that actually kind of, I would say I'm at like 84% now, so it's good enough. The result type is a flexible way to store success failure states that you need to cache or are not ready to process yet. Oh yeah, that's what I want to ask it too. As you grow as a Swift dev, oh, we read that part. So yeah, I want to ask it about the storage or the application of like to what do you mean store, and how for how long? You know what I mean? In the context of SwiftLang's results type. What is stored, and for how long, and what are some applicable use cases in the domain of ETL. So for the uninitiated, ETL is just, it's an acronym for extract, extract, transform, load. It means less and less these days, but you'll still hear it thrown around. But it more or less nowadays is really more of a, it's less descriptive about the actual process, because a lot of times it is not, it's no longer in that particular sequence. But either way, it's just describing, you know, data pipelines. People often use it as synonymous with that, although it is not, but that's often what they're talking about. And since GPT read the internet and read all of those misnomers, then it too will hold and know exactly what we're talking about. Duration of storage, wait, where does it? Okay, yeah. In Swift, the result type is an enumeration that represents either a success with a value or a failure with an error. It is commonly used to handle operations that can succeed or fail, encapsulating the result of a computation or an operation. Here's a deeper dive into what is stored in a result, its duration, and applicable use cases in the domain of ETL. Nice, brother. What is stored in a result type? The result type in Swift is defined as follows: enum, result, success, failure, conforms to Swift standard library error protocol. Two cases, success, and its associated type is the success type, and then case failure, and same thing, associated type failure. Success, this case stores the value, so it's storing the value produced, oh, because it's an instance, so we would create an instance of it like we did, yeah. This case stores the value produced by a successful operation. This type, the type of this value is generic, denoted by success. Okay. Failure, this case stores an error that conforms to the error protocol. This type, the type of this error is generic, denoted by failure. Okay. Duration of storage. The result type itself does not manage the duration of storage. The lifetime of a result instance depends on its usage and the scope in which it is defined. It follows standard Swift memory management rules, including automatic reference counting. When there are no more references to a result instance, it is deallocated. Okay. So you would need to, I guess in my case, like if I wanted to have a running, well, I guess that's not true, but if I wanted to have multiple instances where they can look back at each step in the transformation to track each data transform, I would need to pipe it out to a file or something like that. Use cases in ETL. In the domain of ETL, the result type is particularly useful for handling the various stages of data processing where operations can either succeed or fail. Here are some specific use cases. extracting data. When extracting data from different sources, databases, APIs, files, each extraction operation can either succeed or fail. Yeah, and this was my kind of my issue with, I just remembered something. This was my issue with Go, in that you really got to lean into the error handling, and it just exacerbates Go's lack of, I'll say, elegance. But it's not horrific, but it's not the best. It's certainly not what, I mean, it would have been amazing to have Swift's features when I was writing those programs, for sure. But can't miss it if you never experienced it. So ignorance is, I won't say bliss, but it can be a blessing in a roundabout way. All right, so now, before I dig in there, I wanted to just so you guys can see, and actually, I'm actually just curious too, what that big blob of Swift code is going to look like in Go. Where the hell is it? There it is. Convert to Golang. Awesome tool, by the way, codeconvert.ai. This thing is awesome because, well, I mean, it's an awesome tool. 3 tools: converter, explainer, generator. But mainly that, I don't know if they're still doing this, but I got a lifetime license for $100, unlimited use. It's pretty wild, and I mean, it's fast, and I've yet to find any egregious mistakes, but I mean, I don't know, it might just be using ChatGPT, but just saying, either way, it's a very handy tool. Definitely worth $100 for lifetime use. Okay, this, yeah. All right, convert that. Package main. Okay. Let's go to, what's it called? Just go dev. Playground. Where the hell is it? Playground. There we go. Oh, this shouldn't be there. This Go code translates the provided Swift code for a simple lexicon parser. Define the token struct. It's a bit small. I just want to see what the... So this is expected. You got to import stuff and Go. The structs are pretty similar. Here's a function, t token, empty string. Oh, ooh, wait, what? Ooh, token if t. Okay. Oh, because Go doesn't have enums. That's right. Yuck. Yeah. I mean, yeah, it never seems as bad, but once you experience the power of enums, brother, it would be hard to go back. I'm not going to lie. But everything else, you can see some of the differences in terms of like how things are defined, empty array, you know, but that's minimal. What is the asterisk? Is that a pointer? Return parser tokens position. Yeah, I don't know, but to me, I mean, a bit of it is just like on the whole, it's just harder to read. Although if you, I don't know, it's not horrific. That's all, but it is harder to read for sure. And I never liked the string interpolation, having to do this jazz here. You know, like the whole percent sign, you write your string and then comma and then the value. So you got to just move them, you know, left to right. You can't just name them in the string, which at least in the ETL domain, if you're doing hella transformations and lots of parsing files and all that, a good string interpolation story will certainly matter. But okay, I just wanted to check that out. Okay, so then where were we? Back here, talking to the Oracle about, oh yeah, this thing here. Okay. In the domain of ETL, it's useful for handling the various stages of data processing where operations can either succeed or fail. Yep. Here are some specific use cases. Extracting data. When extracting data from different sources, database, oh wait, we read that already. Okay, so we got that part. That makes sense. Transforming data. Data transformation processes can encounter various issues such as invalid data formats, parsing errors, or transformation logic failures. Transform data, single argument, return the result type, do use a constant equal, then try this, try some function, return success. I see. So apply that function against the data that you're processing, which is what you would have passed in. On success, you want to return the transformed data, the output from the try. Otherwise, catch and handle the error. Okay. Loading data. When loading data into a destination database data warehouse, operations can fail due to constraints, connectivity issues, and other load-specific errors. Yep, it's fucking annoying. Especially the load-specific stuff, just because, I mean, AWS does not make it it's just a lot of fuckery going on. That's all I can really say. It's the best way I can sum it up, brother. Func load data, transform data to database. Oh, that's cool. I like that. Func load data. Return type. Where is the, oh, there it is. Result void. Okay, so these can be anything. This just has to conform, that second parameter just has to conform to the error protocol. We can call the first whatever, but it'll always be the success fail or success error cases, regardless of what we call it. And then do try database. Try because, where's our, transform data. Oh, right. We don't have to, or we can do this inside a do block without having to define the function as throws. Or we could leave out the do catch and define it as throws and just use try. Yeah, okay. Chaining operations. The result type makes it easier to chain operations and propagate errors through the ETL pipeline. Example, func perform ETL. So we pass in a URL. And a database, we return the result type. And we have this constant extracted result equals extracted data. So this is a function, and we would give it the URL. And this would be a conditional on the result. So if it's success, then on the fly create this data what you call it, variable. Let transformed result equal transform data. So whatever that returns will be put into transformed result. Okay. And then we switch on that value in that bucket. On success, we return load data, so another function. Failure, whatever the error is, case failure, let error. Wait, why are there two? Oh, because we have two switch. Okay. Yeah. Okay. The result type in Swift is a powerful tool for handling operations that can either succeed or fail, providing a robust way to manage and propagate errors. In ETL process, it can be used to encapsulate the outcome of each stage. Yeah, which is, at least we're on the same page and in line with what it could do. So I think I'm satisfied with. I'm gonna save this. There's some useful tidbits in there, so we'll just throw that on with this one here. And where are we now? Memory management. Perfect. All right, so we're going to wrap it up for today, folks. So, as always, thank you for watching. And as always, we'll be back tomorrow, yes, on Memorial Day, at the same time, 11 a.m. for a few hours per usual. This is great, because we're almost done with this book, right? Not that it's not a race, right? The important thing is to understand it, but I do feel like I understand the vast majority of what's been covered. So we're making good progress. I'm really trying to get before, because I start my job July 1st. So I'm really trying to make the most of this next month, because I would really like to get through, obviously, this book, which I don't anticipate taking even one more week, doing streaming every day. And there's no reason I can't do that. And I plan to do that. And then after that, we're going to jump straight into a SwiftUI course that I purchased. So much in the same vein, I'll be, narrating, reading out into the ether, streaming that entire process too, learning that as well. So then we'll have Swift covered, SwiftUI. After that, we're going to do a brief, probably, I don't want it to last really more than a stream or two, but we're going to do some schema design for my app and some API design, lay down some groundwork there, just to have some working knowledge of what we're building as we move into the next book, which the next book will be another Big Nerd Ranch guide, but on the Apple specific platform. So instead of deep dive into Swift, then that'll be a deep dive into iOS programming, iPadOS, macOS, and whatever other frameworks are contained in there. Metals, AppKit, probably. I don't know which ones they cover specifically, but that's going to be the next thing. I want to cover, like I said, this book, SwiftUI, that book, and the app design before July 1. So that's the goal. If that's something you want to stick around for, you want to learn about, make sure you drop a follow or a sub or a like or whatever the hell, whatever platform you're on. Just come on back, brother. How about that? And as always, too, 9 p.m. Central, I have another stream that I do, 9 p.m. Central every night, 100 Days of Ranked Halo Infinite. I'm on day 63 tonight, 6 tiers away from my goal. I hit Diamond. Actually, I dropped to Platinum 6. God dang it. That did happen last night, but we'll get it back. But either way, make sure you check that out, too, if you're into that. Otherwise, take care of yourself. Take care of each other. Be nice. And go eat a good meal. You worked hard today. You did a good job. See you guys tomorrow.